This is a quadratic curve. The equation of this curve is given by y equal to ax squared plus bx plus c, where a take the value of 1, b take the value of 4, and c take the value of -5. We notice the quadratic curve cut the x-axis at 2 points. Therefore, we say the quadratic equation has 2 roots. The roots of the equation can be found by setting y equal to 0 and solve this quadratic equation by using the quadratic formulas. With the value of a equal to 1, b equal to 4, and c equal to -5, the roots of the equation is -5 and 1. -5 here and 1. A quadratic curve can cut the x-axis at 1 point as well. And this is shown here. A quadratic curve might not cut the x-axis at all. In this chapter, Roots of Quadratic Equation, we are interested in finding out how many points the quadratic curve cut the x-axis. And is there a way to find out that information without drawing the graph? Yes, there is. What we need to do is to calculate the value of b squared minus 4ac. Now the quadratic curve cut the x-axis at 2 points, and the value of b squared minus 4ac is 36, which is a value greater than 0. b squared minus 4ac is known as discriminant. When the discriminant is greater than 0, it will cut the x-axis at 2 points, and we say that the nature of the root is real and distinct. Now I'm going to change the value of c. Let's see how the curve changes and the value of b squared minus 4ac changes. Now when b squared minus 4ac equal to 0, the quadratic curve will cut the x-axis at 1 point. When the b squared minus 4ac discriminant equal to 0, cut the x-axis at 1 point, and we say that the quadratic equation has equal roots. And the last case, the quadratic curve does not cut the x-axis at all. The b squared minus 4ac will be less than 0. And we say that the quadratic equation has no real roots, or we say it has complex roots. Later we will make use of these facts here to solve some questions. Find the values of q for which this quadratic equation has equal roots. When a quadratic equation has equal roots, it will cut the x-axis at 1 point, and the discriminant b squared minus 4ac will be equal to 0. Let's arrange this quadratic equation in the form of ax squared plus bx plus c equal to 0. Bring over the 2x and bring over the q. So for equal roots, b squared minus 4ac must be equal to 0, which is the case here. Let's find out the value of a, b, and c. A will take the value of q. B will take the value of -2. And c will take the value of q. B is a -2. A is a q, and c is a q. Now we are going to solve this equation for q. Hence q will take the value of plus minus 1. That means if we substitute the q as 1 or -1 into this expression here, the quadratic curve will cut the x-axis at 1 point. Let's verify that. Here we are going to plot the curve y equal to qx squared minus 2x plus q. And we have found out that when q take the value of 1 or -1, this quadratic curve will cut the x-axis at 1 point. Let's try out the value of q equal to 1. When q equal to 1, we can see that the quadratic curve cut the x-axis at 1 point. Another value of q we have found out is -1. When q is -1, the quadratic curve is a set face, and it also will cut the x-axis at 1 point.